square root method. So the first one is 3y squared equals 75. I want to solve for y using the square root method. When we're using the square root method, what you want to do is you want to make sure that whatever quantity is squared would get by itself. So in this scenario, do we agree that only the y is squared? The 3 is not squared. So we want to get the y squared by itself. So anything that's not with that quantity that's squared, we have to move it over to the other side. How will I move this 3 over to the other side? Divide by 3, right? Because it's 3 times y squared, and we want to get the y squared by itself. So we're going to divide by 3 on both sides. And now we're going to have y squared equals 25. Once you get the quantity squared by itself, to undo a square, we're going to take the square root. Now, in chapter 6, I had said over and over and over again, when we're taking the square root, or we're just not actually taking the square root, when we're simplifying a square root, we always just account for the positive version of things. But now we're not just simplifying a square root, we're solving for a variable. When you're solving and you're taking the square root to solve, you have to account for the positive and negative value. So when we square root y squared and we square root 25, we're going to have y is equal to plus or minus 5. And we need to account for both the positive and negative value, because 5 times 5 is 25, but negative 5 times negative 5 is also 25. So when we're just simplifying a square root, we only account for the positive value. But when we're solving, we have to account for the positive and negative. Next one. So if I have 20 n squared equals 4n squared plus 81. Hey, again, I want to solve taking the square root method. So what I need to do is everything that's has a quantity that's squared, I need to bring it over to one side. So what I'm going to do is I'm going to subtract that 4n squared on both sides. So this is going to be 16n squared equals 81. Now, because it is multiplication, technically I can leave the multiplication there. It's more important that if there's a plus or minus sign to move it to the other side. But multiplication we can leave there. But for me, I want to get rid of it. So I'm going to divide by the 16. So we're going to have n squared equals 81 over 16. Now that we have the quantity squared by itself, now I'm going to undo the square by taking the square root. When we're solving, I have to account for the positive and negative value. And I can split this into the square root of 81 over the square root of 16. And this ends up working nicely. Why does this end up working nicely? Ariana? Because they're both perfect squares. So we have 9 over 4. So plus minus 9 over 4. Is anybody still copying this one? Let's say I have 2 times the quantity of x plus 2 quantity squared minus 2 equals 38. Again, we're solving square root method. Because we're solving square root method, we have to get the quantity that's squared by itself. Well, in this scenario, the quantity that's squared is x plus 2. That's our quantity that's squared. So I need to get this all by itself. So I need to get rid of this minus 2, and I need to get rid of this times 2 as well. We'll hold off on this for a second. So for me to get rid of this minus 2, easy fix, what do? I just add it to the other side. So I'm going to add 2 to the left, add 2 to the right. So now I have 2 times the quantity of x plus 2 squared equals 40. Can I distribute in the 2 if I wanted to, that 2 in the front? Can I distribute in that 2? Good. Why the 2 in the front, I'm saying, not the exponent 2. Not distributing this 2. It's 2 times this quantity. Can I distribute that in? How many will say yes? How many will say no? Good. Your algebra 1 teachers will be proud. Why? Why can't I distribute this in? Right.
Is this being squared?
Good. So remember PEMDAS. PEMDAS is always in play, whether we acknowledge it or not. And can I distributing is multiplying? Can I multiply before I do exponents? No, we can't. Should I FOIL this out, do you think? No, because I want to solve square root method. So I want that quantity squared. I don't want to FOIL this out. I just want to get rid of this 2. Well, isn't it 2 times this quantity? Since it's 2 times the quantity, can I just divide by 2 on both sides? So I'm going to divide by 2 on the left, divide by 2 on the right. So now I have the quantity of x plus 2 squared equals 20. Now that the quantity that's squared is by itself, now I can solve square root method. So I'm going to square root left side, square root right side. So the square root cancels out with the squared. So I'm going to have just x plus 2 is equal to plus or minus. Can I simplify the root of 20? Yeah, do it in your head. What's the square root of 20? 2 root 5. Am I finished? No, because we're solving for x, so I'm not done. We still have that plus 2. To get rid of that plus 2, wouldn't I just minus 2 on both sides? So this is going to be x is equal to negative 2 plus or minus 2 root 5. They are not like terms, so I cannot combine them. So I have to stop here. Okay, so now that we've practiced solving square root method, now what we're going to do is we're going to solve by completing the square. Let's go navy blue. So if I have x squared plus 6x minus 7 equals 0. All right. Solving by completing the square is not the most efficient way, I should say. It's not the most efficient way to solve this specific problem. It's not the most efficient way because isn't this an easy factoring? So it would be easier just to factor and solve. But that's not my purpose here. I wanted to choose a simple equation for us to solve by completing the square just to show you the process of completing the square. But generally speaking, we would solve by completing the square on problems that were not factorable. So normally if I were to give you and said to solve this, your best method would just be factor set equal to 0, solve. So if we're going to solve by completing the square, there's a series of steps we want to use. So the first step is going to be keep variables on one side and move constants to the other. Okay, so what do I mean by that? I mean, any term that has a variable in it, we're keeping on the left side. Any term that does not have a variable in it, we are moving to the other side. So do we agree x squared plus 6x stays put? That -7, we're moving to the other side. How am I going to move -7 to the other side? Add 7, exactly. So this is going to become x squared plus 6x equals +7. We good with that? Okay, next step. So now what we're going to do is we're going to take half the x coefficient then square it. Add that number on both sides. Okay, so what do I mean? At this point, these are our steps. We've moved the constant to the other side, so we have x squared plus 6x equals 7. Now we're going to go to the x coefficient. What number is the x coefficient? Well, we're going to, you got to the answer. So the x coefficient is 6. Violet already did it in her head. She took half of 6. What's half of 6? 3. 3. And then you're going to take that 3 and you're going to square it. 3 squared is 9. That product, that 9 is what you're adding to both sides. So this is going to be x squared plus 6x equals 7. So we're going to add 9 to the left side and we're going to add 9 to the right side. You have to add it to both sides to keep it balanced, to not change the value of the problem. All right, next step. We're going to factor the trinomial to be some quantity squared. So this is the whole point in completing the square. We're creating a square. We're factoring that trinomial into some quantity squared. And that will always be the case. As long as you do step B correctly, it will always end up being some quantity squared if you factor it. Does that all work if there is a square? We're going to talk about what to do there. We're actually going to divide it up, and you'll see. So the question, so no. So here what we're going to do is we have x squared plus 6x plus 9. Again, this is easy factoring. Wouldn't it be 3 and 3, right? 3 times 3 is 9, 3 plus 3 is 6. So this becomes the quantity of x plus 3 squared. Equals 7 plus 9, which is 16. And so just to tell you a little bit of a shortcut here, when we know if you do step B correct, that it's always going to be x plus or x minus the square root of whatever this number is. It will always be x plus, and your sign depends on that middle term. So since there's a plus sign for the 6x, it would be a plus. If there were a minus sign for the 6x, then it would be a minus. So it's always the square root of this last number, and then you take that same sign of the middle term if you're going to shortcut that factoring, because it's going to be that quantity squared. All right, now what's going to happen? We're going to end up with a square, some quantity squared equals a number. We can solve square root method. So step D, we're going to say solve square root method. So we have x plus 3 squared equals 16. So we're going to square root. We have to get that quantity squared by itself. It is by itself. So now we square root both sides. What can we not forget to do? Since we're solving, not just simplifying, plus or minus. So we're going to have plus or minus 4. Am I finished here? No, we have to solve for x. So we're going to subtract that 3 on both sides. So x is equal to a negative 3 plus or minus 4. Am I done here? No, because these are actually like terms. So we're not done. You have to get simplified answers. So this would be negative 3 plus 4, or we can have x is equal to negative 3 minus 4. So we get x equals 1 and x equals negative 7. And obviously, we could have done this in like 2 seconds had we just factored and solved. Yes. Yeah. Okay, let's do other problems. Number 2. So again, we're going to solve by completing the square, and we're going to have x squared minus 6x. Oops, sorry. X squared plus 4 equals 6x. X squared plus 4 equals 6x. So this would be a better problem to use completing the square, where you're going to see it's not easy factoring. So if we're solving by completing the square, remember, we want to first make sure all variables are on one side and constants on the other side. Is that the scenario here? No. I need to move the 6 to the left side, and I need to move the 4 where? To the right side. So we're going to have x squared minus 6x equals negative 4. Everybody okay with what I did there? Okay. Now, who remembers the next step in completing the square? Amanda?
We have to say 6 and then square root, so and then add it to both sides.
Yep, not square root it, square it. Perfect. So I don't care about the sign. Don't worry that that's a negative 6. It doesn't matter. Half of 6 is 3. 3 squared is 9. So I'm going to add 9 to the left side, and I'm going to add 9 to the right side. So now I have x squared minus 6x plus 9 equals 5. So now, once we get our trinomial on the left side, it will always be able to be factored, and it will always factor into some quantity squared. In this scenario, what's it going to be? X minus 3 quantity squared equals 5. Now we are going to solve by taking the square root method. So we square root the left side, we square root the right side. So we're going to end up with x minus 3 is equal to plus or minus the square root of 5. Add that 3 over. X is equal to 3 plus or minus root 5. All right, let's do another one. Say I have x squared equals -2 plus 5x. Okay, it's not in a good format, so I want to make it in a good format. I'm going to move that 5x over. So we're going to have x squared minus 5x equals -2. Our next step is to take half of our x coefficient, and this is not very nice, right? Because half of 5 is 2.5. It's not a whole number or some kind of integer. So I don't actually want to change it to a decimal. I want to leave it as a fraction. What does that mean? So if I take half of 5, this is like my thinking head over here on the side. Half of 5 is 5 divided by 2, and I'm going to leave it like that. So I'm going to take that 5 divided by 2, and what do I do after I divide by 2? We have to square it. And I'm still going to leave it as a fraction. So 5 over 2 squared gives us 25 over 4. So I'm going to add 25 over 4 to the left side, and I'm going to add 25 over 4 to the right side. Have I lost anybody here? Are we still okay? All right, now on the left side, I'm going to keep it like this, x squared minus 5x plus 25 over 4. On the right side, in order for me to add these, don't I have to create a common denominator? So I'm going to create a common denominator of 4. So this becomes -8 over 4 plus 25 over 4. So then we have x squared minus 5x plus 25 over 4 is equal to, what does it become? 17 over 4. Yeah. All right. So now I simplified that side as much as I can. So on the trinomial side, we want to factor it into some quantity squared. Remember what I said. This is, well, if we did it correctly, it will always factor into some quantity squared. So I know it's going to be an x minus, and then all you have to do is take the square root of that last number. So what's the square root of 25 over 4? Ariana? 5 halves. And now we solve square root method. So I end up with x minus 5 halves is equal to plus or minus the root of 17 over the square root of 4 is 2. Our last step is to add that 5 halves over, so x is equal to 5 over 2 plus or minus root 17 over 2. Luckily for us, we have a common denominator, so I don't have to create one, but I do have to combine them. So it'd be 5 plus or minus the square root of 17 all over 2. Anybody still copying this one? We're okay? All right, one more, and then we're going to add a leading coefficient. So what number is this up to? 4? So I'm going to have x squared plus 6x root 5 plus 40 equals 0. Don't be scared of that root 5. We're going to go about this the same exact way. My first step is to move the 40 to the other side. And what I'm also going to do is make this 6 root 5 times x. So you recognize that the coefficient is the full 6 root 5. It's not just 6. Equals negative 40. So don't be scared of that root 5. We're going about this the same way. We take half the x coefficient. What's half of 6 root 5? 3 root 5. And I'm going to take that 3 root 5, and what am I going to do? Square it. So doesn't that become 9 times 5, which is 45? So I'm going to add 45 on the left. I'm going to add 45 on the right. Oops. Why did I write equals? This is plus. Now, didn't I say as long as we did that second step properly, this will always be some quantity squared? And that quantity squared will always be taking the square root of that last number. So you can right away take the square root of 45, and I hope you can do it in your head and know that it's 3 root 5. Or you can just recognize, well, I got 45 by squaring 3 root 5, right? So it has to be that 3 root 5 that I squared. So I'm going to write x plus 3 root 5 quantity squared equals 5. Now to undo a square, we're going to take that square root. So I have x plus 3 root 5 equals plus or minus root 5. Our next step is to subtract that 3 root 5. So x equals negative 3 root 5 plus or minus root 5. Can I leave it like this? No, because they're like terms. What do I mean when I say they're like terms? Yeah, they both have the same radicand, meaning I can actually add or subtract them. Do we agree there's a 1 here in front of that root 5, the second root 5? So this is going to be x is equal to negative 3 root 5 plus 1 root 5, or negative 3 root 5 minus 1 root 5. So x will equal negative 2 root 5, or x will equal negative 4 root 5. Okay, let's talk about what happens when we have a leading coefficient. Here's number 4, in case you're still copying. Anybody still copying this one? We're okay? Bathroom? Yeah. All right. Let's say, what do we do when the leading coefficient is not 1? So when the leading coefficient is not 1, we have to make leading coefficient equal to 1 by multiplying or dividing. Are we ready? So again, we're solving by completing the square. I have 3x squared plus 4x is equal to 7. I cannot complete the square if the leading coefficient is not 1. So I need to make that leading coefficient 1. So we're still going to go through the same steps. I'm going to move whatever constant to the other side. Has that already been done for us? Yes. Now I'm going to realize I can't complete the square because my leading coefficient is not 1. So I have to ask myself, through multiplication or division, what can I do to make this equal 1? Divide by 3. But can I just divide one thing by 3? No, to keep this balance, I need to divide everything on both sides by 3. So I'm going to divide every single term by 3. So now we end up with x squared plus 4/3 x is equal to 7/3. So now it's not as easy, but we can still complete it. So the rule says now go to your x coefficient and take half of your x. Think about this, guys. I'm going to take my x coefficient, which is 4/3, and I'm going to take half of that. Taking half is dividing by 2 or multiplying by 1/2. So I have 4/3 times a half is equal to 4/6. I'm going to keep it as 4/6. So I'm going to take 4/6 and then I'm going to square that 4/6. So if I'm taking 4/6 and squaring it, I get 16 over 36. So I'm going to add 16 over 36 to the left, and I'm going to add 16 over 36 to the right. So you can. This helps me do the factoring easier. That's why. But it would still work. So now what we're going to do is I'm going to now factor this. X squared plus, and now I'm just going to take that square root of the 16 over 36. If I take square root of 16 over 6, what do I get? 4/6. Quantity squared equals, now I'm going to create a common denominator. My common denominator is 36. So I'm going to multiply top and bottom by 12. So I'm going to have 84 over 36 plus 16 over 36. So now you might be seeing why I've chosen to leave everything sort of with the higher without simplifying. But like I said, if you chose to simplify, it would still work out. So now you're getting x. Oh, why did I write x squared here? Sorry, nobody caught that. So it should be x plus 4/6 quantity squared equals 100 over 36. So essentially, this is why I did it. To undo a square, we take the square root. So now I'm going to have, why do I keep writing squared here? Sorry. This is going to be x plus 4 over 6 equals plus or minus 10 over 6. Is everybody okay with how I got plus or minus 10 over 6? Now your last step is to subtract that 4 over 6. So x is equal to negative 4 over 6 plus or minus 10 over 6. And so now we have to get our two answers. So negative 4 over 6 plus 10 over 6, or negative 4 over 6 minus 10 over 6. So now we end up with 6 over 6, which is 1. And then we end up with negative 14 over 6, which simplifies down to negative 7 over 6. So we have two answers here, x equals 1 or negative 7 over 6. Oh, not 6 over 3. Thank you. I want to show you one more together, and then I'll have you try one on your own. One eighth n squared minus a half equals n. First question for you, is this in a good format? No, so I want to move the half to the other side, but not only do I want to move that negative a half to the other side, don't I also want to move the positive n to the left side also? So we're going to have 1/8 n squared minus n equals positive a half. Now are we at least in a good format there? Okay, now my next problem is I can't complete the square when our leading coefficient is not 1. So I can do this through multiplication or division. What would I have to multiply or divide 1/8 by? What would be the better option? Multiply or divide by something to get it to be 1? Violet? Excellent. I want to multiply by 8. Let's just pretend this was 3/8. It's not 3/8, but let's just pretend if it were 3/8, what would I then multiply by? 8/3, exactly. But it's not 3/8, it is 1/8. So we're going to do that. So now I need to multiply every single term by 8. So now I end up with n squared minus 8n equals 4. Not so bad anymore, right? Half of 8 is 4. 4 squared is 16. So I add 16 to the left, I add 16 to the right. Easy factoring, we love this. N minus 4 quantity squared equals 20. To undo a square, we take the square root, and we end up with n minus 4 equals plus or minus 2 root 5. Add that 4 to the other side, n equals 4 plus or minus 2 root 5. All right, I'm going to have you try one on your own, and then you'll be done. Okay, try this one on your own. 3z squared minus 12z plus 4 equals 0. And you're solving by completing the square. So I'll give you a minute and then we'll go over it. All right, let's go over this. All right, so what did we start off by doing? Maddie? Charlie? Moving the 4 to the other side. So we have 3z squared minus 12z equals -4. Do we all agree our next step would be divide by 3 under everything? So now we have z squared minus 12 over 3z equals -4/3. All right, not as easy. We take the 12/3 and I have to take half of that. So that's multiplying by a half. So that becomes 12 over 6. Oh, this ends up working nicely. So if we do a half of 12 over 6, what's this time I would simplify this. What's 12 over 6? 2. So I would do that. So here we're going to have z squared. Oops, sorry. We're going to add 2 to both sides. So plus 2. Oh, sorry. We got to square it. We got to add 4 to both sides. So plus 4 plus 4. Now here's the thing. Oh, guys, 12 over 3 is 4. What did I do? I wanted to make this harder and I didn't. Sorry. So there we go. Oh, so this isn't a hard problem. Is it a hard problem? No, it's not. It's easy. Oh, I'm mad at this. Okay, so now we're going to factor this. So this becomes z minus 2 quantity squared. We do have to make a common denominator, so there's something. Multiply top and bottom by 3. So you have -4/3 plus 12/3. Oops. So now we have z minus 2 quantity squared equals 8/3. Square root both sides. Z minus 2 equals plus or minus. Oh, this is a little bit better than I thought it would be. Okay, why? What do we have to do? Amanda. Yeah, we have to rationalize. Who remembered that? Good. So now we have z minus 2 equals plus or minus 8 root 24 over 3. Can I simplify the square root of 24? So z minus 2 is equal to plus or minus 2 root 6 over 3. Add that to. To be honest, I would accept plus or minus. I would accept it like this. But if the number were like 2 plus or minus 3/4, do you think I would accept that? No, because you can actually add these and combine them. So you would have to make a common denominator and then add them. But for this, I would leave it. I would accept it just like this. If you were to make a common denominator, that would also equally be as good. But does everybody understand why I would accept this, but I wouldn't accept this? Anybody confused on that? Okay, we are done for today. You do have homework.